inequality notation uses inequality symbols such as greater than or equal to, greater than or equal to. So, since it didn't record, obviously, let's go ahead and talk a little bit more about that. So we use inequality symbols to describe all possible values for a given set. Now, just like last time, we had taken a look at our example here, and you'll notice that we have a graph here, and we would say that this data is continuous data. It is connected. A very common misconception is continuous means it has an arrow. That is not true. Continuous is connected, just like we stated on page. We have several things that appear on a graph. Solid dot. Now these solid closed circles are inclusive parts of data into the value. And whenever we have solid closed dots, this type of inequality are equal to. Now we don't always have solid dots. Sometimes open or empty exclusive, and obviously not include the value. So whenever we have exclusive bits of data, aside from solid dots or open dots, my arrow can go up or down. It could also go to the left or to the right. Now, whenever you have arrows that go up or to the right, these are pointing towards positive values, although if you have arrows going down or to the left, those are pointing towards negative values. Now, arrows do not mean that something is continuous. Infinity. Now, infinity is something that we cannot count up to, so it is not a number. Instead, idea encompassing all possible numbers in the known universe. Now, because infinity is not a number, and it keeps going on and on and on forever and ever, we wouldn't be able to include it. So infinity would be inclusive. So again, or less than symbol. Now, I know it seems kind of strange, but just trust me whenever I say, and I'll explain in just a little bit, anytime you have an arrow that is pointing to the left or down, creating a negative infinity, greater than symbol. Although in the positive infinity, it'll be associated to the less than symbol. Now, I know that a lot of people who use inequality notation, they get it wrong, mostly at the part where they have to use the actual inequality symbols. So what I want to do is simplify it, and I only want to use less than or equal to or less than symbol, using the one example that we have to the right. What I'm going to do is your choice completely is I'm going to highlight my relation in yellow, just you know sometimes it's hard to see it on these lines. Now, the reason I highlight is just so that we can see where it begins and ends. Going back to freshman year, we learned about domain, and we learned that it involves values, just like we stated there on the set notation portion. Now, because of that, we would say that we read left to right. So let's go ahead and take a look at this yellow relation beginning on the left-hand side. I've labeled the x-axis because I want to see where this yellow relation crosses my x-axis. Beginning on the left side, I in here at -2. I went ahead and drew a solid line through the entire graph that crosses the x-axis at -2. I chose a solid line because I had a solid dot, and that means that it is inclusive. So let's go ahead and begin by writing out that value. 2. Because I'm reading from left to right, I don't really have to think very much because I know I have a solid dot. I'm going to go ahead and write this inequality or equal to. Because I'm dealing with the x values, my next step is x. Now we're going to go ahead and travel over to the right-hand side, and at the very end of this yellow function, we find an arrow. So I'm going to go ahead and draw a dashed line through here, and we already said that if we have arrows, that means infinity. Now this arrow in particular is pointed to the right. So I would say that it is a positive infinity, and I would write the following: less than infinity. Now do know that it is not necessary to write the infinity symbol, because I know a lot of you guys don't like it anyway. Instead, we could actually cut it off right here. Now, do you recall whenever we had spoken about inequalities before and how they can seem a little bit confusing? Now, right now it says negative 2 is less than or equal to x. And that doesn't really sound like it's describing this domain, the range of this domain. So I'd like to go ahead and rewrite it like the negative 2 less than or equal to x, and we're going to rewrite it as x is greater than or equal to negative 2, which is kind of like what we see whenever we flip this around. Now, x greater than or equal to negative 2 definitely describes the values, my x values, starting here at negative 2. Now let's go ahead and take a look at our range, which in y values. For those of you who had me freshman year, you might thumbs up. You can also show that, in case you can't write that tiny, an arrow going up, or a horribly drawn tree. You plant a seed and it grows up into a tree. So let's go ahead and take a look at our yellow function, and starting at the bottom, we negative 1. Again, I drew a solid line because I have a solid dot, so let's go ahead and write that in. Negative 1, because it's solid, we're going to draw the inequality with a solid line below, and it's the y value. So lastly, let's go ahead and follow it all the way up, and again, we have an arrow. This arrow is pointed not only to the right, but also in an upward direction. So less than infinity. Now, we can also rewrite this without the infinity sign. Is greater. Lastly, let's move into interval notation. If you don't recall, comma, parentheses. So let's go ahead. For each continuous section of the graph, write starting and ending points separated by a comma. That part is particularly important. Now, we're going to use our parentheses and brackets at different points. So let's we use parentheses exclusive data. And lastly, we have a weird symbol that looks for a horseshoe shape. This U shape represents, and it brings different parts of a function or a relation together. So let's begin with our first example, and I'm going to make that a little so we can ensure that we can see everything. Again, we're going to be working with our domain first, and we read our domain to right. So let's begin on the left-hand side of this yellow relation, and that seems to have a solid dot 5. Now, because I have a solid dot, inclusive 5. Now remember, it must separated by a comma, the starting and the ending point. So we start on the left, then we're going to move on over to the right, and again I find so since it's a solid dot, that means it's again inclusive, and I would so let's recall bottoms up. So let's start at the bottom of my yellow relation, and it looks like again we have 4. Because it's inclusive, I need to beginning. Don't forget to follow your move over to your ending point, bottoms up. Again, we're ending with inclusive. Now, you don't have to write this part down if you don't want to, but I'd like you guys just to compare this to inequality notation. I'm going to write that out in pencil so it's not. I don't know, if you'd ask me, I'd say I really do enjoy interval notation a bit more. It's nice and clean, very precise, to the point, and doesn't have a whole bunch of stuff that I might get confused with. So let's move on to the next example. Some of us have already. Now this example is a little weird because it's a two-parter. We're going to be doing the exact same which we said we read from left to right. So I went ahead and highlighted this function. I'm going to start on the left-hand side, and what an arrow. Because it's an arrow, I would say it's exclusive. That's why I drew a dashed line. Now this arrow appears to be pointed up, but I don't care about up and down for domain. So not only is it up, but it seems to be slightly to the left. So I would call negative infinity. Now again, we said that this is exclusive, so we need to have a parenthesis to begin. Let's go ahead and follow that with our comma and mosey on over towards the right. And that's the end of my first piece. If 1, I find an open circle, so that's exclusive. So after the 1, I would put parenthesis. Now, we had talked about having multiple parts of a relation, and we put them together on a graph using our union symbol. So since I have one part, to move over to the next part, and let's continue moving from the left towards the right. And we would begin with 2. And since we have a solid dot, that means we have an exclusive bracket, comma, and now we can go ahead and continue moving on towards the right, and we find positive 5. So since it's open, that means we have an exclusive parenthesis. Now that wasn't some intense work just for our domain. Now range is going to be a little weirder, so let's again bottoms up. So let's look at the bottom of this yellow function. So taking a look at the bottom, oh dear, I have a lot of stuff going on here. So I see a solid dot and an open dot, and they both seem to be here at -3. Now, the best is to think about that hole here. So, very clearly we have a hole. Now, on that same hole, because what we're doing is we're taking this data and we're kind of just only looking at the y values. So I am not including -3 here, but I am including it here. Now, I don't care about x values, I only care about y. So exclusive and inclusive, so it kind of does this, and it fills in the hole. So, because I have at least one solid point here, that means we are -3. So let's go ahead and continue moving on up. So as I go up, So I'm going to go ahead and just kind of do a reveal here. Moving on up, so I have another open circle, but I also have solid lines here that are going to fill it in. So let's keep on moving till we find the end. Ooh, we have a tip over here, kind of like an apex of a absolute value, but oh, we continue going. So let's keep on going until we no longer see the yellow relation. And here we go. So it looks like my relation is ending right over here at this arrow. And this arrow is pointed up. So in that case, I would say positive infinity, which is exclusive. Now we can finally do our last. Unfortunately, some of our lines didn't appear on to our zero. I'll try my best to draw them on there. I'm sorry about that. Again, bad copies. That's why I went ahead and highlighted them in yellow. Let's go ahead and left side. I also darkened up my x and y axes just so I could see it. So if this is 0, 0, it looks like my left side with an open circle. So there's inclusive parentheses. And let's continue traveling towards the right, where I negative 1 bracket. Again, we have two parts, so we need union and continue all dot exclusive and continuing to the right arrow a parenthesis. All right, let's starting at the bottom. I have 0. And I think here would be a good time to use our big reveal again. So I'm going to get my paper and I'm going to cover. So I start at the bottom and I see an open circle at 0. And I'm just going to continue going until I don't see my yellow oh, it looks like it breaks apart here. Now the thing is, since I have a solid circle here and a solid line here, there is no part where it is disconnected yet. So I do have another part, but they are both included. So I'm going to go ahead and keep moving on up. And I see another inclusive circle and an inclusive line, but it looks like it keeps going. So, oh, here we go. I'm finally at the end. And what do I find at the end but another arrow? And this arrow is pointed exclusive. So we should have finished up our set notation and inequality notation. Now you are done with interval 22 and put into the binding of your notebook. This will help you tremendously with Friday's assignment, Monday's assignment, Tuesday's assignment, and will get you prepared for your semester exam. See y'all then.